Hi, welcome back to Caddy Discusses. I'm Emily Arnott, and today I'm joined by my coworker Aaron to discuss value analysis, value engineering. This is a practice that a lot of manufacturing shops are adopting recently and seeing really good results. But at the same time, there's ways to do it well and ways to do it poorly. And I think before anybody rushes into this process, it's best to learn these sorts of best practices from, the experts. So, Aaron, why do you think it is that so many manufacturers are eager to implement something like VAVE?
Uh, well, the trite answer is everybody wants to reduce cost. They want to produce things more cheaply. But actually, value analysis, value engineering as a practice, I mean, those two things disaggregated independently are intended to not just reduce cost, but also improve functionality, or maybe let's say reduce cost while maintaining quality. um, the deeper why of VAVE, like why do people invest in VAVE now? It's the same reason manufacturers are investing in any other initiative that's designed to reduce cost or improve productivity. It's because American manufacturing in particular is in the midst of an existential crisis. A lot of people don't think about this actually in this way because the human brain is not really all that well designed to think about deep history. But American manufacturing on the global stage actually peaked in 1956 in the post-war era. So in 56, America controlled 60% of global manufacturing output. That's a huge number. By 2001, America controlled only 28%. What share of global manufacturing output do you think we command today?
Based on that trend, I'm going to guess somewhere around the 7 to 8%.
Oh, slightly better than that. Okay.
Okay, all right.
15.9, but it's still not great, right?
Yeah.
If you call it 16%, that's essentially a 44% slide across the span of essentially one lifetime. That's pretty precipitous. Over that, if we want to shorten the time horizon, if anyone listening thinks to themselves, all right, well, that's the 1950s. There's no other established economies in the world. You're wrong. But that aside, if we want to shorten the time horizon, we want to just think about from the early 2000s till now. There are other like really kind of semi-terrifying stats to think about that are motivating manufacturers. In 2001, there were conservative estimates say about 350,000 independent manufacturers operating in the US. How many do you think there were in the year 2021?
I would guess again, if it's a decline of this sort of magnitude, maybe down to 200,000-ish.
That's pretty good, about 240,000. So a 30% reduction in the number of manufacturers actually operating in the US. That's a massive wave of consolidation, right? So both the industry output is getting smaller as we sort of offshore more and more work, as the manufacturing industry started looking to, or American manufacturers rather, started looking to Mexico, Canada, China, importantly, and shifting production over there. It's been hard for smaller independent manufacturers to continue to survive. So we're in this environment where really only the strong survive. Only the biggest players can make it because they have what many might be familiar with, the term economies of scale. Right, so the biggest guys can leverage the scale at which they operate to reduce cost and compete on cost. Now, of course, quality is an expectation for everybody. So it's increasingly hard to find space to compete on quality. What this really means is any manufacturer who wants to not just thrive, but fundamentally survive in this environment, anyone who wants to stick around needs to be invested in constantly looking for ways that they can reduce cost without sacrificing quality. So enter VAVE, value analysis, value engineering. These are processes that manufacturers are turning to try to increase efficiency, both operational efficiency and productivity and quality of their outputs in the early design phase of the project by bringing in more stakeholders who can weigh in on the potential implications of any given design choice. And then, of course, value analysis, which is looking at line by line individual component parts within a larger assembly to see where can we reduce cost, where can we save by consolidating our purchasing, by, again, maybe changing a small design choice. So these are great tools. They're timely tools. They're difficult if you have, if you don't support your team adequately by giving them certain types of machine learning or artificial intelligence resources to help identify the data needed to do value analysis or value engineering. But if you are supporting those teams appropriately, there's a lot of money to be had here. So people are taking it really seriously.
Mm-hmm. But I think you've touched on something very relevant here when you mentioned the difficulties of it, that VAVE can be quite labor intensive. And I think it's something else where the big dogs have an economy of scale of labor as well, that if they're launching a product, the volume is sufficient and they have enough people that it's trivial to spend the additional time digging through past results, doing this sort of manual comparison, figuring out where efficiencies lie. Okay, we can get this component, which is functionally equivalent at a cheaper price. But those insights, they don't just kind of fall out of the tree naturally. So what really interests me is, how does VAVE work for the smaller players? How does VAVE work when you don't have that seemingly infinite labor pool? And I think you've kind of touched on part of the answer, which is you need to supplement this technologically. So, I think the biggest thing technology has always done for us is just make access to information trivial. Instead of manually looking up something in a filing cabinet, now it lives on a computer file. Instead of having to call up somebody that may know something, it lives in a central repository. And that's sort of the major advances that all of these manufacturing shops have seen since, say, the 80s, this sort of digitization of things. But what I'm curious is, what is your experience with kind of the latest and greatest in those advances? Like, how does it get even more convenient than a spreadsheet or a file folder?
Well, there are a few things in there that I think I want to challenge you on.
Oh, for sure.
The first idea being that the bigger players are actually having an easy time of doing VAVE because they can leverage bodies, or they have enough people to throw at the problem. I actually think that's a challenge that's felt by all, big and small. Especially in the United States, manufacturing has been struggling with this skilled labor problem for well over a decade now. If you look at the FRED database information available on the size of the workforce and at labor productivity, you start to get this really grotesque picture of what American manufacturers have been experiencing since the Great Recession. It's essentially like the labor pool has been shrinking. Part of that is we haven't really supported manufacturing education in the way that we would have needed to. We haven't placed manufacturing in the right place culturally, where people really value manufacturing jobs. They don't think of them as being sexy. It's not a sexy career path for a lot of folks. But the other thing too is, today we have a very aggressive, hostile immigration policy that's going to shrink our labor pool even further. So both for skilled and unskilled labor. So no one really has the free bodies to just throw at data analysis and data gathering problems. The other thing I got to challenge you on is, there is obviously a paradigm for data storage that has been created. At one point, that was a binder or a file cabinet. Digitization is happening in this industry. I say is currently because I don't want to give the misimpression that digitization is done, especially for the little guys that you just described. Many folks are still operating in an analog way. And maybe they are maintaining some of their information on spreadsheets, but as you pointed out, it's incredibly difficult to aggregate from there. The big players many of them have turned to other forms of data storage as a paradigm. So this gets us into a conversation about PDM, product data management, or PLM, product lifecycle management. That's a data storage and interaction paradigm that some of the big players like Dassault and PTC and Autodesk have really pushed people on for about a decade now. Of course, all of those major players have a heavy investment in driving everybody towards the utilization of 3D CAD, ignoring the fact that the vast majority of design, documentation, and manufacturing still exists in a 2D format. But the thing that those tools really don't do is actually help people get anything out. I think the big fundamental problem with the PLM paradigm is the same problem actually with the file cabinet, and that's that these become graveyards of data and information. It's where all of that goes to die, basically. And for anyone on your team to successfully retrieve information from these storage systems, they need to have deep understanding and familiarity with your business, right? So you need a 20-year engineer who has seen similar parts designed over and over and over again and knows where they've been left and put to go find something in a file cabinet or in a PLM tool. That's incredibly problematic to leave all of this individualized knowledge with a single person, especially considering many of those folks are now approaching retirement. I just had a very interesting conversation. I spoke very briefly at Women in Manufacturing in Seattle 2 days ago, and had a very interesting conversation with a couple of members of the design team from Ventura Foods, who were sharing that that company had really started all the way back in the 40s. So if you think about that, the original guys and gals who were working on design or in manufacturing, they retired. Mm-hmm. And they were replaced by a new cohort somewhere in the late 70s, early 80s, who themselves now are reaching retirement. So we're actually 2 generations now removed from some of the original design choices and like the original core bedrock of understanding of how the business operates. Mm-hmm. So for the new folks trying to pick up the baton, you're inherently playing telephone already. And that assumes that that second wave of 40-year employees really stick around to actually pass the baton to you. Basically businesses like this just cross their fingers and hope that the folks are there long enough. Kind of makes me wonder how manufacturing companies reacted to COVID and the potential loss of mindshare when that was happening. But you asked me really, what is the current paradigm, right? What's the latest and greatest? And here I am sort of detailing why the old paradigm is a major miss. The latest and greatest is that the folks who are trying to do this on a regular basis, who are trying to do VA and VE on a regular basis, are equipping their teams with specifically machine learning tools. The beauty of machine learning in supporting VAVE is in that it's great at pattern recognition. And one of the hardest things to do in a VAVE exercise is identify and extract from a data set of 2 million drawings, the 5 to 10 that are actual duplicates of one another, or are close enough to be considered similar or near duplicates. That's incredibly difficult. Even harder than that, if you can figure out where those duplicates are, even harder than that is then going about collecting all of the associated data that's attached to those designs. So all of the purchase orders, supplier documentation, design notes, quality defect reports, supplier corrective action reports, everything that basically somebody who's doing VA or VE would need to figure out what supplier they want to buy from, figure out how to modify the design to reduce cost or improve operational capability. All of that is much more easy to bring together if you're leveraging machine learning tools. So
Mhm.
that's what folks have been trying to turn to. In fact, I just spoke with some analysts from Gartner earlier today about this topic, and that's been sort of a key hot button thing on most of their engineering executive roundtables, going all the way back to the very end of 2023. So we're really now about a year, call it a year and a quarter, year and a half, into a serious discussion among manufacturing leadership about how AI and machine learning can play a role in this. But yeah, VAVE is one of the most important areas that manufacturing leaders are looking to support because it has such a direct relationship to the bottom line. You know, if a company like Subaru can do an analysis of all of their value analysis of all of their fasteners and affect a 3% cost reduction just in that component of what they do, for a business that is generating upwards of 87 billion in annual revenue, the cost savings are enormous. So it's a very, very clear, straightforward investment area for most manufacturing leaders.
This is all really good points, and I really appreciate you calling me out on my assumption that there exists somewhere a mythical infinite pool of labor, because you're absolutely right. Even for the big players, there is a very significant shortage of labor and a labor gap, and not just a gap in terms of roles going unfulfilled, but a gap that's created when somebody is replaced, when someone retires and takes with them all the institutional knowledge that they built up over years. Even if you have someone in that position on the very next day, they're not going to be performing at that level or having those insights. And VAV is such a longitudinal process. Like, it's something that is empowered and works because of all of the data you've accumulated, all of the decisions you've made in the past, all of these reference points. And I think what we're finding is that those gaps in labor really kind of create a stumbling block for this sort of implementation.
I can double down on that and frame it to you in another really interesting way. So if we just want to isolate value engineering for a moment, there are certainly cost savings to be achieved here. But the other part of what a company is trying to achieve, right, is maybe operational efficiency improvements. We want to improve productivity or output. Part of the role of value engineering is to find better processes to go about creating a product that meets the spec or the requirement of our customer. And that process, value engineering, should be integrated as one of the first steps that a design team goes through. And it should bring in inputs from a lot of different stakeholders, from production all the way down to your supplier base. So if you want to do this well, it takes a little bit of time. And for most OEMs, certainly true also for tier one suppliers, but for most OEMs, time to market is a significant factor in their ability to win that market. So the pace at which you can do VAVE exercises has a direct impact on your ability to win markets and scale revenue growth. Think for a moment again about our Subaru example. If Subaru takes 4 times longer to finish their value engineering process as they're trying to build the next model Subaru, and they release it 8 months later than their closest direct competitor, they're behind and they're missing out on revenue and an opportunity to take market share. So this is a really, really important process for people to not just think about in absolute terms with respect to cost. It's also really important for people to recognize that just because you can brute force your way through doing VAVE by throwing people at and giving them time to find the data doesn't mean you should, right? Because you're missing an opportunity to win in your market.
Mm-hmm. This really highlights something for me too, that a technological solution by its nature for VAV or for anything else is always going to scale better than a manual solution, right? So for these big companies, not only do they scale in terms of volume of output, they're also scaling in terms of the information they're generating. And if you have a manual approach to sorting through these files, doing value analysis, finding comparable, more cost-effective solutions, that scales wildly out of control when you have hundreds of thousands of past designs to churn through. Whereas a technological solution, it doesn't care. You can throw it 10,000 points of data, 100,000 points of data, a million points of data, and within roughly the same time parameter, you're going to start getting these insights back. You're going to start getting the relevant things floated up with the relevant information points highlighted. So I think with VAVE, yeah, what a lot of people are finding is that it's that big unknown, the labor cost, because they're estimating, they're kind of basing their assumptions of how time intensive and how much of investment it's going to be on people doing things manually. You know, oh, we had to look up a previous design last week. It took an hour, and you're telling us to look through all of our previous designs to try to find cost savings. There's no way that that's going to save more money than that time takes. But the technological solution is the X factor here for VAVE.
That is a really funny thing to think about, right? Because for most major manufacturers, discrete manufacturers, when they're doing a VAVE exercise, one of the big areas of savings that they're looking for is labor cost, albeit just as a direct input to a product line, right? So they're thinking to themselves, can I change this design and go from, say, like 2 45-degree angles in what is essentially an L curve just to 190-degree and reduce my time in tooling or the the human labor associated, and that's very straightforward for folks. But what often feels less straightforward is the time and labor hours associated with the engineer who's responsible for the design, because of course that cost of the engineer doesn't scale in the same way that the direct input cost of production scales. That said, it's still significant. We've said a lot of things historically about the cost associated with the current search paradigm period. For engineers, for procurement folks, how much time are they spending? How much are you paying them? That's also a very easy equation to put forward. Of course, not every manufacturing leader who hears that equation, I think, has such a granular vision of their back office employees' contribution to the overall economic output of the company, which just tells you something about where manufacturing has been focused for so long. But yeah, these areas of the work process also need to be optimized, right? You can't ignore engineering, you can't ignore procurement. You do need to support these folks if they're going to be successful. Both because it produces better economic results for the company, but also because these are human beings, right? And if you want to retain top talent, you do have to be able to give them the opportunity to do the work that they find fulfilling, to do the fun stuff. Because if you don't, your competitors will. These tools are available. It's really difficult to make the case in a post AI or post ChatGPT environment that a new engineer who's coming out of grad school, maybe if they've got a master's in design engineering, should be spending their time combing through file cabinets for 4 hours a day to find a reference point. That's a tough sell for somebody walking into the labor force.
Yeah, that's not going to help with the labor gap in manufacturing if that's the sort of sexy job they're looking at. If I can suggest sort of a pithy summary to what you've said, it's sort of the bad news is you've been neglecting optimizing your back office work. But on the other hand, the good news is that you've been neglecting to optimize your back office work. And I think that's why VAVE has become such a rewarding practice for so many people to undertake, is that there's still a lot of relatively low-hanging fruit in that area. If you haven't really thought about, the design process and you've just been kind of doing the same thing year in, year out, you likely will find in short order, if you're well technologically equipped to do this in a labor effective way, once you undertake VAVE, you really will find savings. Like, they really are just waiting for you in that back office.
Yeah. I think this is actually like a really tight segue into this statement that should be said, right? Many of the folks who watch this already participate in a VAVE practice. All right, this discipline has been around for some time. There are people with VAVE in their title. So companies have recognized that this is valuable and they've started to make the investment, many of them. If you are in a scenario where your company is not yet making an attempt to do this, and you're trying to get started, that's okay. You have a whole bunch of low hanging fruit, Emily, as you just articulated, especially if you enter that process first adopting machine learning tools that are designed to help you find the data. You will identify the low hanging fruit real quick. That said, if this is a practice that your company has been maintaining for some time, then you're having more of a conversation about how do we make it repeatable? How do we make it scalable? How does it become less ad hoc? There also, I think, supporting the team effectively by handing them the right tools is probably a really solid step. But there's more to consider, like where are you going to get the most bang for your buck between call them platform or core components and non-core components. Where do you want to focus first? I referenced Subaru taking a look at fasteners. Companies can find and will find, based on the way that they manufacture parts, different areas that represent a higher ROI for them to tackle. The through line, though, is if you really want to maximize the capability, or you maximize the effect of VAVE practice, whether you're starting from scratch or you're trying to optimize, you need to make it consistent and scalable. If you can't do those things, then you're only going to recognize the benefits on an ad hoc basis.
I think that's a great way to put it. And I would really encourage people, like, the foundation here, I think, is kind of two types of information. There's the actual data that you need to make available in your systems, but then there's also sort of a strategic wisdom to VAVE. Like you said, certain product areas are going to be more or less capable of generating savings. There's good targets and bad targets, high priority and low priority. And so I would just really encourage people to get educated as much as you can about VAVE. If you click down in our description on our website, we have a series of blogs that I think illustrate a lot of really great use cases around VAVE. And we have a whole white paper coming out soon that you can download to get a complete guide on kind of getting started and choosing your first few ideal VAVE products. So I hope you see this video just as a jumping off point in your VAVE education. Aaron, would you like to add anything as a closing thought?
Well, maybe a shameless plug, Emily, for your blog. The thing that we didn't discuss was the impact of tariffs. And I won't say a lot there. What I will say is the tariffs put sort of a new lens on specifically the value analysis aspect of VAVE, where even if you've recently done value analysis to identify opportunities for you to reduce cost with bulk buying, a shifting tariff environment is realigning the input costs for you as we speak. And it's a very fluid environment out there. So I highly recommend everybody check out your blog on tariffs. And if you're interested in having a discussion about those, about how you can navigate a shifting cost input landscape a little more effectively, we would love to talk to you about it. So don't hesitate to reach out on LinkedIn.
Yeah, I'm looking forward to these very somber conversations about the shifting and sometimes perilous economic world in which we find ourselves. But being informed and being agile, that's your ship in rough waters. So let's all climb aboard.
Hey, there's always opportunity somewhere.
That's right. That's right. There's always a window that's opening now. All right. I've been Emily Arnott. Thank you so much for joining us.
I'm Aaron Lober.
And please subscribe if you've been enjoying these conversations. We'll have more coming soon. Have a great day.